All right, we're going to go ahead and go over the review for the quadratic formula test that's coming up. And so the first thing we're going to be asking is to solve using, first of all, the square root method, which is not the same thing as the quadratic formula, although you could use the quadratic formula on these problems, but I would not recommend using that when you have an equation that only has an x squared term and does not have an x term. So like this one. So we're going to get rid of the 37 first because what we're trying to do is isolate the x squared term. So I'll bring down the 3x squared. 10 minus 37 is negative 27. All right, now I'm going to get rid of the 3, divide by 3. So x squared equals negative 9. Now, there's a problem here because when you square a number, you should not get a negative value. So when I take to get rid of the square, I would do plus or minus the square root, but we do not have the square root of negative 9. There is no such thing as the square root of negative 9, so that is no solution. So anytime you work these out and you get the square root of a negative, that is no solution. All right, let's take a look at number 2. Now we're going to get rid of the 7 first. Remember, even though you see a minus sign, there's a plus in front of the 7. So we would subtract the 7. Be very careful here. We have a negative in front of that x squared over 4. Negative 2 minus 7 is negative 9. All right, so now we're going to get rid of the 4. So we're going to multiply both sides by 4. So I have negative x squared equals negative 36. Remember, there's an understood negative 1 in front of the x squared, so now we will divide by negative 1. And negative 36 divided by negative 1 is a positive 36. And finally, x is plus or minus the square root of 36, which is plus or minus 6. So if we write the answer in set notation, that would be negative 6 and positive 6. All right, let's take a look at number 3. Number 3, we have, again, another equation where there's only an x squared term. So I'm going to get rid of the minus 7 first, add 7. So 2/3 x squared equals 5 plus 7 is 12. Now we'll get rid of that 3 by multiplying by 3. So 2x squared equals 36. Now we'll get rid of the 2, divide by 2. 36 divided by 2 is 18. So now the final step to get rid of the square, we do plus or minus the square root. And of course, 18 is not a perfect square, so we are going to have to factor it. 18 is 2 times 9. 9 is 3 times 3. So this would be plus or minus the square root of 2 times 3 times 3. If we have a pair of 3s, we're going to pull it out. So this would be plus or minus 3. The 2 does not have a pair, so it stays on the square root. So our solution set, I'll have to write it over here because we don't have any other room. It's negative 3 square roots of 2 and positive 3 square roots of 2. All right. And continuing on, number 4. Okay, this one is a little different. Um, we do not, we have a square in here. So the first thing I'm going to do is get rid of the square. So a lot of times we get rid of the square last, but since it's on the outside of a parentheses, we're going to take the square root on this. So square root of 25 is 5, but it's plus or minus 5. Then we have to add 4 to both sides to get rid of the minus 4. So what this is 4 plus or minus 5. That means we're going to do 4 plus 5, which is 9. And then we're going to do 4 minus 5, which is negative 1. So the solution set, negative 1 and positive 9. Continuing on with the next part. Again, we're going to solve this problem. So we're going to get rid of the square. So I'm going to take the square root plus or minus the square root of 9. Plus or minus the square root of 9. That's plus or minus 3. So now I'm going to get rid of the 1. So this would be negative 1 plus or minus 3. So negative 1 plus 3 is 2, and negative 1 minus 3 is negative 4. So our solution set is negative 4 and positive 2. All right, so there are four possibilities when we're solving quadratic equations. You could have no real solution. That is when the discriminant is 0. Okay. Or excuse me, not when the discriminant is 0, when the discriminant is less than 0. All right, we'll just go through these. First of all, number 6, discriminant is a positive and a perfect square number. So when you take the square root of a perfect square, of course, you're going to get a nice number. So these are rational, two distinct rational solutions. Okay, number 7, discriminant is positive, but we do not have a perfect square. And by the way, the discriminant is this part of the quadratic function or the quadratic formula. So this is the part under the square root in the quadratic formula. So that's what we're talking about when we say discriminant. So number 7 is, of course, irrational because it did say positive, but not a perfect square. Now the discriminant is negative. Well, you can't take the square root of a negative number, so that is no solution. Okay, and then when the discriminant is equal to 0, that only results in one solution. Okay, so these are things you have to memorize right here. 6, 7, 8, 9, you have to memorize these. All right, let's look at number 10. We're going to solve this. First, we're going to find the value of the discriminant. So this is nice because it's equal to 0 because the discriminant needs the equation to equal 0. So remember, we're going to do b squared minus 4ac. In this case, b is negative 24, a is 16, and c is 9. So here's your a, here's your b, and here's your c. So negative 24 squared is 576. Yeah, I'm going to probably need my calculator here. Um, all right, so I'm going to go 4 times 16 times 9, which is 576, but there was a minus sign there. So 576 minus 576 is 0. Remember, go back if you forget. B was the answer to when the discriminant was 0. And so that is one rational solution. Whoops, sorry. One rational solution. By the way, sometimes instead of one rational solution, they say two identical rational solutions. So one rational solution is the same thing as two identical. Because if you have two of the same thing, you really have one thing. Okay. Let's look at the next one. Continue with the discriminant. So again, the discriminant is b squared. Remember, here's your 1 squared minus 4 times a times c. Be careful with those negatives right there. 1 squared is 1. Now, when you're doing this second part, you're going to do negative 4 times negative 3, which is positive 12, times negative 5 is negative 60. 1 minus 60 is negative 59. So that's a negative value. So this is no real solution. All right, number 12. Again, we're going to use the discriminant. That's b squared minus 4ac, negative 5 squared minus 4 times negative 2. Negative 5 squared is 25. Negative 4 times 4 is negative 16. Negative 16 times negative 2 is a positive 32. So this is 57. Okay, so that is positive, but this number is not a perfect square. So this would be 2 distinct irrational solutions. Okay. Continuing on, number 13, b squared minus 4ac again. So this is 15 squared minus 4 times 2 times 7. 15 squared, 15 times 15 is 225. 4 times 2 is 8. 8 times 7 is 56. So 225 minus 50. Oh, I don't know why I wrote 57. Excuse me. All right. So 225 minus 56 is 169. Now, in case you don't know, 169 is a perfect square. If I take the square root of that, it's 13. So 169 is a perfect square. So this would be two distinct rational solutions. All right. Now we're going to use the quadratic formula to find the solution. So the reason we're using the quadratic formula is first of all, the direction said so. And sometimes you can't use the quadratic formula. That's the only thing you can use is the quadratic formula. This actually ends out factoring. If I factored this, it would be x minus 5 times x plus 2. Negative 5 plus 2 is negative 3, and negative 5 times 2 is negative 10. So that would factoring would work here, but you have to do whatever the directions say. So if the directions specifically say use the quadratic formula, it is not acceptable to solve the equation using some other method. It's fine to use the equation, use the factoring method, to check your answer if you want, but no, you cannot solve the equation using some other method if the directions specifically say use the quadratic formula. All right, so here is our A is 1, our B is negative 3, and our C is negative 10. So we have a formula opposite of B plus or minus the square root of B squared minus 4AC, all divided by 2A. So we're going to plug this in. I want to point out that this formula is on your reference sheet, so that's helpful. So negative B, so that's like a negative 1B, by the way. So that's like negative 1 times negative 3 plus or minus the square root of B squared, negative 3 squared, minus 4 times A is 1, C is negative 10, all divided by 2A, 2 times 1. Okay, so this is 3 plus or minus the square root of negative 3 squared is 9. Negative 4 times 1 times negative 10 is 40. 2 times 1 is 2. All right, and then 9 plus 40 is 49. So this is kind of nice because 49 is a perfect square. Square root of 49 is 7. So now you have to work this out. You have to do 3 plus 7 divided by 2, and then you have to do 3 minus 7 divided by 2. So 3 plus 7 divided by 2, that's 10 divided by 2, which is 5. 3 minus 7 is negative 4, divided by 2 is negative 2. So our solution set is negative 2 and positive 5. Okay, number 15. Again, here is your A, here is your B, and here is your C. So x equals the opposite of B or negative 1B. I think of it that way, really. Negative 1B. It's the same thing as the opposite of B. Plus or minus the square root of B squared, negative 13 squared, minus 4 times A is 6, C is negative 5, and then all divided by 2A, 2 times 6. So negative 1 times negative 13 is 13. Negative 13 squared is 169. Negative 4 times 6 times negative 5. That would be, if you use your calculator, that's probably a good idea. Whoop, let's see here. Looks like I lost my calculator. Put it back up here. All right, so here we go. Negative 4 times 6 times negative 5. So this is a positive 120. 2 times 6 is 12. 169 plus 120 is 289. Okay, so you might need your calculator for this if you don't know this already. Square root of 289 is 17. So that worked out nicely also. So now we have to do two problems. 13 plus 17 divided by 12 and 13 minus 17 divided by 12. 13 plus 17 is 30. 30 does not divide evenly by 12, but we can divide the numbers by 6. 30 divided by 6, 12 divided by 6. Okay, so it's 5 over 2. Over here, 13 minus 17 is negative 4. Negative 4 over 12 is negative 1/3. All right, so our solution set is negative 1/3 and positive 5/2. Okay, and I just realized we didn't write the solution set on the last problem. I should do that. So it's negative 2 and positive 5 for the last problem, back on number 14. Okay, and then we're moving on to now number 16. Okay, we have A, B, and C again. So x equals negative 1b, negative 1 times 20, plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So this is negative 20 plus or minus the square root of 400 minus 4 times 25 times 4 is 400 also over 50. So this is negative 20 plus or minus the square root of 0. And the square root of 0 is 0. So whether you add 0 or subtract 0, you're going to get the same number. It's negative 20. And then negative 20 over 50 reduces to negative 2/5. So there is only one real solution here, and that is negative 2/5. All right, let's continue on. This one, we have answers that are going to be irrational. There's going to be radicals in this. Okay, negative b, so negative 1 times negative 2, plus or minus square root of b squared minus 4 times, remember, a is 1, c is negative 2, all divided by 2 times 1. Negative 1 times 2 is negative 1 times negative 2 is 2. Negative 2 squared is 4. Negative 4 times 1 times negative 2 is positive 8. 4 plus 8 is 12. Okay, and then we got a little problem here because 12 is not a perfect square. 12 is 2 times 6. 6 is 2 times 3. So 12 is 2 times 2 times 3. So you have a pair of 2's. So the square root of 12 is 2 square roots of 3. All right, and we have a common factor here of 2, so we can divide everything by 2. So 2 divided by 2 is 1. 2 square roots of 3 divided by 2 is just the square root of 3. And 2 divided by 2 is 1. We don't usually write that 1. It's just 1 plus or minus the square root of 3. So the way we write the solution set is, whoops, sorry, it's not right, is 1 minus the square root of 3 and 1 plus the square root of 3. All right, number 18, we're getting a little more complicated here. We have to move everything over because we need an equal 0. So sorry about that. So we're going to move the negative 4x over, it becomes positive 4x. We're going to move the positive 3 over, it becomes negative 3. Now we can use the quadratic formula. Negative 1b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times 1. Negative 4 plus or minus the square root of 16 plus 12. 16 plus 12 is 28. All right, so 28 is 4 times 7. 7 is 2 times 2. So not a perfect square. We have 2 times 2 times 7, a pair of 2's. So the square root of 28 is 2 square roots of 7. All right, now we have a common factor of 2. Negative 4 divided by 2, 2 square roots of 7 divided by 2, and 2 divided by 2, which I'm not going to, of course, we're not going to actually put over 1. So it'll just be negative 2 plus or minus the square root of 7. So in set notation, negative 2 minus the square root of 7 and negative 2 plus the square root of 7. All right, now we have, you notice they left you a lot of space here because there's going to be some work that's going to have to be done here. So the first thing we have to do is figure out what is x minus 3 times x plus 1. So we need to make a box. So this is x squared plus 1x minus 3x minus 3. Like terms right here. So the left side is x squared minus 2x minus 3. We still have that equals 4x plus 1, so we're going to have to get rid of him because I need a 0 on the right side. So those cancel. Get rid of that. Those cancel. And so we have x squared minus 6x minus 4 equals 0. All right, so now we're ready to use the quadratic formula. X equals negative 1b, negative 1 times negative 6 plus or minus the square root of b squared. That's a negative 6 squared minus 4. Remember, this is a 1 times a times c, all divided by 2 times a. Negative 1 times negative 6 is 6. Negative 6 squared is 36. Negative 4 times 1 times negative 4 is positive 16. 2 times 1 is 2. So this is 6 plus or minus the square root of 52 over 2. So once again, I'm going to have to factor this. Okay, 52 is 2 times 26. 26 is 2 times 13. So 2 times 2 times 13. I have a pair of 2's. So this would be 6 plus or minus 2 square roots of 13 over 2. Can divide everything by 2. 6 divided by 2 is 3. 2 divided by 2 is 1, but we don't usually write a 1 in front of a radical. And so the final answer is 3 plus or minus the square root of 13. So 3 minus the square root of 13 and 3 plus the square root of 13. All right. And we're down to the last one, number 20. X minus 2 squared equals 2x. So I need to make a box again. Because remember, when you're squaring a binomial here, what you're really doing is multiplying it by itself, x minus 2 times x minus 2. So this is going to give us x squared minus 2x minus 2x and positive 4. These combine together to give you x squared minus 4x plus 4. Don't forget that 2x is still there. I need a 0, so I'm going to have to get rid of that 2x. So x squared minus 6x plus 4 equals 0. All right, x equals the negative 1b time plus or minus the square root of b squared minus 4. A is 1, c is 4. All divided by 2 times 1. All right, so this is 6 plus or minus the square root of negative 6 squared is 36. Negative 4 times 1 times negative 4 is 16. 2 times 1 is 2. 36 minus 16 is 20. All right, so I'm going to have to simplify because that's not a perfect square. 20 is 2 times 10. 10 is 2 times 5. So 2 times 2 times 5. So 2 times 2 times 5, that means that the square root of 20 is 2 square roots of 5. Now we can divide by 2. So this is 3 plus or minus the square root of 5. So our solution set is 3 minus the square root of 5 and 3 plus the square root of 5. All right, that concludes the review. Hopefully, you got all of these right. But if you got things wrong, pay attention to the mistakes that you made. Go back and look at those again. Make sure you don't make those same mistakes again on the test. And good luck.